physics, and through this we are going to do practicals in physics under the machines. And these machines, we have the types of pulleys. We have different pulleys, and we have the single fixed pulley, and we have the block and tackle pulley. So we are going to deal first with this single pulley. And this single pulley, we are going to use this string to exercise on how it can be applied. Here we see that this fixed pulley, it can be applied to uplift the small loads that can be used okay, it can uplift the small loads that can be contained in the baskets or buckets that can be uplifted up to the building site for construction or repair work. So this pulley, we have this string here that you see. This string, it has the load. And this load, it is used to hold this string to show us the velocity ratio that we have here. So this pulley, it has the velocity ratio, that is the number of string that passes to the wheel. So it has passed once. That means that our velocity ratio that we have here, it is 1. So, and this, we have our second pulley that we're going to look at. And this pulley is this one. The one that we said is called the block and tackle pulley. The second one, and we are going to start with it. Continue with it. We have our block and tackle pulley. It looks like that, and we have also the string. And this string, it is going to help us to know the number of velocity ratio we have in this pulley. We have our second pulley here, and we are going to use this string to tie our first wheel, which is the smallest wheel, that is going to be attached to another wheel. This is our first wheel that is going to be attached here. And through this wheel, this is our first string from this knot. It has passed to show us the number of times that it has passed to our first string, means that this is our first velocity ratio that we have here, and we are going to continue. With our continuation, we are going to attach the small wheel to the smaller wheel that is on the top. And this, it can show us very well that we have our second velocity ratio. From this point we said up to this point, it is our first velocity ratio. And from this point up to this second wheel here, it's our second velocity ratio. So we are going to continue to get our third velocity ratio here. It is passing to our third wheel. From this third wheel, it is passing to our fourth wheel. This is our fourth wheel. This is our fourth wheel, and through this fourth node, we are going to pass it from our third. Yeah, it is well. This is our fourth wheel here now. So students, as you look, it clearly indicates that we have our first block tackled wheel and our second block tackled wheel. From this, we cannot balance these wheels until we have our load. This is our load that we can put down here to balance and help us to count the number of velocity ratio that we have here and how these wheels and these pulleys is going to be applied. So we said our first velocity ratio is going to pass from this point up to this point. This is our first velocity ratio. Our second velocity ratio, it goes round like this up to this second wheel. This is our second velocity ratio. Our third velocity ratio is going to pass from this point up to this point. So this is our third velocity ratio that we have. Our fourth velocity ratio is going to pass from here up to this point. And through this, you can, this is our fulcrum, this is our effort, and this is our load. So when you have these four velocity ratio, it is going to help us to calculate some calculation that we have in our books. Since we have our diagrams in our books, we cannot calculate using our practicals. So you will be told to find the mechanical advantage. Mechanical advantage, it is being found through our load over effort. When we have our load and effort, you are going to find the mechanical advantage. Secondly, you are being told to find the velocity ratio. The velocity ratio, we have already found it here, and we've known that our velocity ratio from this pulley, it is 4. And finally, you will be told to find the efficiency. Efficiency, it is always in percentage. So when we have the mechanical advantage and we have the velocity ratio, our efficiency is going to be mechanical advantage over the velocity ratio times 100 to find the efficiency percentage. So if we have these pulleys can be applied as to help us to construct the lifts and the cranes. So when we have this one, the lift, the functions of the lift, it can uplift or it can go down. So this is the application of this pulley. It can be used to construct the lifts and the cranes. So this is where our topic ends, and if we have any question, we can continue with it. You can ask, but for now, our topic has ended from there, and have a blessed day. Thank you.